example. So we've talked about, you can see a very physical product here, but wanted to also share with you news about another technology partnership that we have. So at AVEVA, we are really looking to push out the boundaries of what can be achieved with technology. That means very often exploring new areas. For us, we have been looking at quantum computing. We know it's in the very early stages still, but we believe that it has the huge opportunity to help us help our customers to do things faster and at scale, and to manage some very complex data sets given its unimaginable compute power. So from a sustainability standpoint, it's very exciting too, because it requires a lot less energy to get to the same results. So as we continue to grow the amount of data that we need, it will be very important to understand how industry in particular can use this new space of quantum computing. So we have signed a memorandum of understanding with Oxford Quantum Circuits, and you'll be hearing from Gerald Mullally in a second more about that. But just to give you a sense of how early this is, there are only 6 working quantum computers in the UK. So early, but very promising and an exciting space to be in.
Brilliant. Well, thank you very much, Lisa. Maybe a little bit of background about OQC, or Oxford Quantum Circuits. We spun out of the University of Oxford in 2017. We were the first commercially available quantum computer in the UK. We hooked it up to the cloud, and we were the first quantum compute as a service company in Europe. Very recently, we did something completely unique. We're the first company in the world to integrate a quantum computer into a commercial or a co-location data center. Might seem small, but that's a huge step for quantum. It's where classical compute exists, and on that basis, it will have to be where quantum exists. That will allow customers to be able to access quantum securely and at low latency. In other words, within their own digital ecosystem. Now, for everyone here, what is quantum is probably a good starting point. Fundamentally, it's a new type of compute. It enables you to solve certain types of problems exponentially faster. And ultimately what that means, and your chair summed it up lovely earlier on, there's digitization and then there's sustainability, decarbonization. If you're able to solve certain problems exponentially faster, you're then utilizing much less compute. And overall what this does is it decouples the relationship between computational power and energy use or energy consumption. And that's a real step forward potentially for the future. So the types of problems that we look at are those that have significant number of variables that interact in a complex way. And usually these are intractable to classical compute. So this could be anything from very complex scheduling to inventory management to production planning, and also grid optimization, where you've got supply, demand, and then the insertion of new renewable energy types can make it very difficult to be able to optimize the grid in the right way. Those are the types of challenges that quantum will be very good at in the future. It is an emerging technology, and I think that's important to state, but I think it's wonderful, absolutely fantastic to have AVEVA as a partner for this and the journey that we're going to go on. And I think I have to say, more generally, we interact, we engage with lots of companies around the world. It's actually wonderful to see a global leading software company now engaging with quantum and thinking about what that can do for their customers in the future. For customers out there of AVEVA, we're really keen to partner more generally to build out the first use cases, to prove out the potential of this technology, and then into the future, hopefully, it will underpin a lot of the industrial intelligence that AVEVA is striving to create. Thank you.